Okay, so the idea now is to talk about Henry's law in gases. So Henry's law talks about what's the concentration of dissolved gas in liquid. And Henry's law assumes that the temperature, let's assume that it's constant, we'll talk about it later, and it tells me that the concentration of a gas in a solvent, in a liquid, equals a constant. It is called Henry's constant, which depends on the gas, which depends on the solvent, which depends on the temperature, times the partial pressure of the gas we are talking about. So you can see that the concentration of a gas in liquid is directly proportional to its partial pressure of that gas. If you look at it, for example, you can see here, this is a gas and this is, I don't know, some liquid. And there is some gas in the liquid, but if I increase the pressure, I take more gas to be dissolved in the liquid. I increase the concentration of the gas inside the liquid when I increase the pressure. You can also understand that when I decrease the pressure, going in that direction, I decrease the concentration of the gas in the liquid, and what happens is that bubbles can be created in that direction. And this may be very problematic, for example, in diving. When the divers dive, the pressure increases because when you dive, you increase the pressure. So more gas, for example, nitrogen, is dissolved in their tissues. But when the divers ascend, the pressure decreases. When the pressure decreases, according to Henry's law, the concentration of gas, for example, nitrogen, decreases. And what happens is that this decreasing concentration causes gas bubbles to form. And this is the mechanism by which decompression sickness happens. So what we see in decompression sickness in divers is after they dive, when they dive the pressure increases, but when they go up, the pressure decreases. So the partial pressure of the gas inside their body, especially nitrogen, also decreases. So as they ascend, the pressure of the nitrogen in their body decreases. And according to Henry's law, the concentration of the gas, the nitrogen, inside the body liquid, also decreases. And it creates bubbles. And those bubbles cause the decompression sickness. They can be in tissues, in blood vessels, and cause complications. This is how Henry's law helps us understand decompression sickness in divers. So again, Henry's law, assumed temperature constant, states that the concentration of gas equals a constant, or Henry's law constant, which depends on the gas, on the type of gas, on the type of solvent, and on the temperature. For example, when the temperature increases, the solvability usually, not always usually, decreases. And on the partial pressure on the gas we are looking at. And it talks about the concentration of the gas in the liquid, for example, in the body or something. And it is very important for understanding decompression sickness. So this is it. This is about the Henry's law for ideal gas, that I can say that this satisfies the ideal gas law, PV equals nRT. Anyway, this is the Henry's law for concentration of gas inside the liquid. Thank you very much, and that's it. If there are any mistakes or correction, please write it down.